All right, in today's video, we're going to talk about the rhombus. That's another special parallelogram. And the rhombus is a parallelogram with four congruent sides. So I'm going to highlight that. Where's my highlighter? There it is. So let's go thicker. So a rhombus is a parallelogram with four congruent sides. And because the rhombus is a parallelogram, we know that it has all those different properties of a parallelogram that we've been discussing throughout the unit. So we talked about opposite sides congruent, we talked about opposite angles congruent, we talked about consecutive angles that are supplementary, and that the diagonals bisect each other. Well, the rhombus has a couple special properties, and the first one is that the angles are perpendicular to each other, all right? So when they bisect each other, they're going to create 90-degree angles, and that's important. And also that the diagonals bisect the pairs of opposite angles, okay? So these angles here are bisected by the diagonals in a rhombus. All right, let's take a look at example 1. Example 1 says, in simplest radical form, find the perimeter of a rhombus with diagonals 12 inches and 18 inches. So I think the first approach here is to let's draw it. So I'll draw that. And let's go around the horn. I think that's just to help us out. And then I'm going to draw my diagonals. All right, so it says that the diagonals are 12 inches and 18 inches. So I know that if the diagonals bisect each other, okay, so if AC is 18 inches, and if I know that BD is 12 inches, well, if they bisect each other, then I know that this point is going to be 9. And from the point where they meet to the vertex there, well, that has to be 9. And the same on the other side. This is 6, and that is 6, because they were bisected. Okay, now, we need to find the perimeter of the rhombus. So, remembering our property that we just went over, they bisect each other at right angles. So I can draw my right angle in here. Okay, so that's my right angle. Well, if I'm looking for the perimeter, I'm looking for this side here. Let's go red. Let's call that X. Well, we have a right triangle, and we know we can find the missing side of a right triangle using the Pythagorean theorem. So let's do that. So I'm going to have a squared plus b squared equals, well, x squared. And that's a little too thick for me. I don't know what's going on. Why is it not? Okay, there we go. All right, so I'm going to have 6 squared plus 9 squared equals x squared. Okay, when I put that in my calculator, I get 117 equals x squared. Okay, so I need the square root of 117. All right, that's going to equal x. Well, simplest radical form. Well, I'm going to think of a perfect square that goes into it. Well, square root of 9 times square root of 13. I can simplify square root of 9, so it's going to be 3 square root of 13. Okay, so that's one side. So x equals 3 times the square root of 13. So I know that all the sides of the rhombus are congruent. So I can multiply 3 times the square root of 13 times 4. So I'm going to do that. So the perimeter equals 4 times 3 times the square root of 13. All right, so I'm going to multiply that, and I get it equals 12 times the square root of 13. All right, let's go down to number 2. In rhombus ABCD, the diagonals intersect at E. If the measure of DAC is 18, find the measure of angle ABC. So again, let's draw that. and you should do the same. So I have A. Okay, so I went ahead with my drawing here, just to expand it a little bit bigger or make it bigger so that you can see it. So what I have here is rhombus ABCD around the horn. I have it intersecting at E, the two diagonals, and then I have the measure of angle DAC is 18. So if I follow along, DAC is 18, that turn. Um, I need to find the angle measurement ABC. So that's this angle measurement right here. So let me get a little highlighter going. So that's ABC. This is what I want to find out. Now, I filled in there that the other side, that angle CAB is 18 also, because that diagonal, one of the properties, all right, what it does is it bisects the angle. So I know if DAC is 18 degrees, then CAB is 18 degrees. Now, how am I going to find angle ABC? Well, what do we have here? We know that, let's go a different color. We know we have a rhombus, and we know that the sides of a rhombus are congruent. So if I highlight, let's use a different color, this triangle, well, you should start to think that that is an isosceles triangle. All right, so we know that in an isosceles triangle that the base angles are congruent. Okay, so if CAB is 18 degrees, then ACB has to be 18 degrees. So that's also 18 degrees. So I'm going to fill that in, 18. So how do I find B? Well, in that triangle, I know that the sum of the measures of a triangle are equal to 180 degrees. I know that those two angles of the triangle equal 36, so that's 36 degrees between the two of them. So I can go 180 minus 36, and the answer is going to be that ABC is 144 degrees. Okay, example 3. If a quadrilateral is a parallelogram with two consecutive sides that are congruent, would this be enough to prove that it is a rhombus? Well, that's pretty straightforward, actually. So if I have a quadrilateral, and the two consecutive sides, so that's going to be, I'll just pick this one and the side next to it. Well, if they're congruent, well, is that enough? Well, yes, it is, because it's a parallelogram, and we know that the opposite sides of a parallelogram are congruent. So a side has to be congruent to its opposite, and this side has to be congruent to its opposite. So yes is the answer. Yes, due to opposite sides of a parallelogram are congruent. So if two consecutive sides are congruent, I'm going to go over here. Sorry about that. All sides must be congruent. All right, now, to prove you have a rhombus, because next we're going to talk about the coordinate plane. All right, to prove you have a rhombus, there are a couple of steps that you can take. One is to prove that all sides are congruent. You can prove that the parallelogram has perpendicular diagonals, or you can prove that the parallelogram has two consecutive congruent sides. All right, so what we're going to do is we're going to set this up, our quadrilateral on the coordinate plane, and then we're going to set up our coordinate proof. So I'm going to do that, so why don't you do that, and we'll talk in 1 second. So the approach I'm going to take to prove that the quadrilateral is a rhombus is I'm going to prove that all the sides are congruent. And I know I can do that using the distance formula. So I'm going to write down my distance formula. Well, I can use my distance formula, but I'm actually not going to. X sub 2 minus x sub 1, and that's squared, plus y sub 2 minus y sub 1, and that's squared. But we know that instead of using the distance formula, we can use the Pythagorean theorem because, and you've seen this before, if I draw that, then my side AB is the hypotenuse. So I can set up the Pythagorean theorem to find out the length of AB. And I can do the same thing for CB, DC, and AD. So what I'm doing is I'm just counting, okay? So I'm counting from A to this point. So that's 3, and that's 4. All right, and then I'm doing the same thing for each side, because on each side, my side length of that quadrilateral, or that parallelogram, is going to be the hypotenuse. All right, so for side AB, it's going to equal side AB, and I just counted that. It's going to be 3 squared plus 4 squared equals c squared. All right, again, this is, just in case you're having difficulties, all right, this is a right triangle, and that side AB is the hypotenuse. So I can use the Pythagorean theorem. So I know that 3 squared is 9, 4 squared is 16 equals c squared. I get 25 equals c squared, and 5 equals c. Now, I know some of you out there are going, Mr. Dixon, isn't that just a 3, 4, 5 triangle? And the answer is yes, it is. Okay, now, so I'm going to do the same thing for side AD. So side AD is from this point up is 3, all right, over is 4. So that's going to be 3 squared plus 4 squared equals c squared. And just for time's sake, we know that c here is going to equal 5. Okay, I have to go around and, because I'm proving all the sides are congruent, or that's my goal. So I'm going to write down side DC. All right, side DC, I'm going to count 3, 4, 3 squared plus 4 squared equals c squared. And then 5 equals c. And the last one is side BC. All right, so if I count, that's 3, 4, 3 squared plus 4 squared equals c squared, and 5 equals c. Now I can write my concluding statement. I can say that quad AB CD is a rhombus. Due to all 4 sides are congruent. Next page, you're going to write down your key ideas, check your understanding, and we will check that tomorrow. Go Cats, go Knights.